Have you ever thought about the tiny battles happening inside your body? I'm talking microscopic warfare, parasites invading your cells, hijacking your systems, and escaping into the night like slick little spies. Sounds like a sci-fi movie, right? But it's not. This is the real-life story of one of humanity's oldest enemies, malaria. And the star of this microscopic thriller? A clever parasite from the genus Plasmodium with a life cycle so sneaky and complex, it puts James Bond to shame. Let's rewind to a warm evening somewhere near the equator. A female Anopheles mosquito buzzes in for a late-night snack. She's not just sipping your blood for fun, she's got eggs to lay. But what you don't know is that she's carrying something extra in her saliva. A swarm of Plasmodium Sporozoites, the first form of the malaria parasite. When she bites you, she injects these tiny invaders directly into your bloodstream, and the heist begins. The Sporozoites don't stick around in your blood for long. They're on a mission, and their first target is your liver. In just minutes, they slip into liver cells and go into stealth mode. Here, they multiply silently by the thousands. Think of it like a parasite training camp. One sporozoite enters, and in a matter of days, tens of thousands of Merozoites emerge. It's like a Trojan horse, but inside your own cells. Now, if we're dealing with Plasmodium vivax or Plasmodium ovale, some of these parasites decide to hit pause. They turn into hypnozoites, dormant forms that can nap inside your liver for months or even years, then suddenly wake up and launch a fresh attack. So even if you think you're cured, the parasite might just be lying in wait. But let's say we're dealing with Plasmodium falciparum, the most dangerous kind. The newly minted Merozoites burst out of your liver and flood into your bloodstream. And this is where things get wild. The Merozoites start invading your red blood cells, like they own the place. Inside each red blood cell, they go through a dramatic transformation. First becoming ring-stage trophozoites, then mature trophozoites, and finally schizonts. These schizonts are like parasite piñatas, bursting open to release even more Merozoites. Each cycle of invasion and explosion leads to waves of symptoms: fever, chills, sweating, over and over again, every 48 to 72 hours, depending on the species. That's the classic malaria cycle people dread. But not all Merozoites are just looking to party and destroy. Some take a different career path. They develop into Gametocytes, the male and female versions of the parasite. They chill out in your bloodstream, waiting for another mosquito to come along and take a bite. Because the next phase of the malaria life cycle? It doesn't happen in you. It happens in the mosquito. So now we're back to another female Anopheles mosquito, drawn in by your body heat and the smell of carbon dioxide. She bites, takes in your blood, and along with it, those sly Gametocytes. Inside her gut, the Gametocytes wake up, turn into gametes, and mate. Yes, actual parasite romance is happening in a mosquito's belly. The fertilized parasite forms a zygote, which stretches out into a long, wiggly ookinet. This ookinet doesn't just sit there. It digs through the mosquito's gut wall and settles in, forming a little oocyst. Inside this oocyst, the parasite multiplies once more, creating thousands of new sporozoites. Eventually, the oocyst bursts, and the sporozoites migrate to the mosquito's salivary glands, ready to start the cycle all over again. So the next time this mosquito bites a human, the parasite gets its ticket back into the bloodstream. Rinse and repeat. This is how malaria survives, by living in two different worlds. One in us, and one in the mosquito. The human body is where it multiplies and causes symptoms. The mosquito is where it mates and regenerates. It's a deadly partnership that's been refined over millions of years. And it's why fighting malaria is so tricky. We're not just up against a single parasite. We're facing an entire life cycle, split across two species with multiple stages and clever disguises. But here's the hopeful part. Every stage of this life cycle is a potential target for scientists. Stop the sporozoites from entering the liver, and the infection never takes hold. Block the Merozoites from invading red blood cells, and you prevent the fever and symptoms. Prevent Gametocytes from forming or being taken up by mosquitoes, and you break the chain of transmission. It's like stopping a heist by intercepting the robbers at any point in the plan. That's why mosquito control, bed nets, anti-malarial drugs, and vaccines all play a role. They don't just treat malaria. They interrupt its story. And the more we understand this story, the life cycle of malaria, the better we can write a different ending. So the next time you hear the hum of a mosquito, remember, it might just be carrying one of nature's most brilliant, most dangerous little parasites. But with science, strategy, and a lot of teamwork, we're We're getting closer to turning the tables on this age-old villain.